concept of antimatter. In modern physics, antimatter is defined as matter composed of antiparticles, which are essentially the mirror partners of the particles that make up ordinary matter. For every type of particle, such as a proton or electron, there exists an antiparticle with the same mass but opposite electric charge and other quantum properties. For example, while a proton carries a positive charge, its counterpart, the antiproton, carries a negative charge. Antimatter isn't just a science fiction idea, it's a real phenomenon, though it's incredibly rare in our universe. Tiny amounts of antiparticles are produced naturally, like in cosmic ray collisions or certain radioactive decays, and artificially in particle accelerators. However, assembling even a small amount of antimatter is extremely challenging due to the cost and the difficulty of containment. Now let's dive into what happens when matter and antimatter meet. When a particle and its antiparticle collide, they annihilate each other in a powerful burst of energy, mostly in the form of gamma rays and sometimes neutrinos or other particles. This process releases energy according to Einstein's famous equation, E equals mc squared, meaning the energy released is proportional to the total mass involved. This annihilation happens near other matter. The resulting radiation can be absorbed and transformed into heat or light. Interestingly, antimatter particles can also bind together, just like ordinary particles do. For instance, a positron and an antiproton can form an antihydrogen atom. Scientists have even managed to create anthelium nuclei in laboratories, though these are extremely difficult to produce and observe. One of the greatest mysteries in physics is why our universe is made almost entirely of ordinary matter with so little antimatter present. According to theory, the Big Bang should have produced equal amounts of matter and antimatter, but observations show a clear imbalance. This puzzle is known as the matter-antimatter asymmetry, and the process believed to have caused it is called baryogenesis. Scientists are still searching for answers, using advanced tools like the Fermi Gamma Ray Space Telescope, which has detected bursts of antimatter from thunderstorms on Earth. Despite these discoveries, the reason for the universe's preference for matter remains unsolved, making antimatter one of the most intriguing topics in modern science.